All right, number 41. So this section was a little bit difficult to grasp because you have to read the chart, and the chart can be divided into many different ways. So for question 41, we are looking at this specifically, this chart, and and what's written there, and specifically note 1. So let's read this. It says determine the approximate landing ground roll distance. So the pressure altitude is given. That's sea level. So we see that. That's here. Check off. So we're at the right mark. Headwind is 4 knots. And the standard temperature is standard. We don't need to worry about that. So the current ground roll is 445. But we want to know, determine the approximate landing ground roll distance. So that's the ground roll we have now, but we need to have that adjusted. So this is what it would be if we multiplied at 100%. If we were to multiply this by 100%, we get the same answer. But the key word here in this question is it says there's a headwind of 4 knots. And because that's the case, we do not have 100% anymore. There's going to be a decrease. And we decrease every, we decrease 10% every 4 knots. So right now, we're at 100%. All right, that's given. But because of these 4 knots, we have to go down 10%. So 100 minus 10% gives us 90%. So now, when we multiply that, or 445 times 0.90, we get 401 feet. And that is our answer. Number 42 involves several steps. So we have a 50-foot obstacle. So where does this leave us at? Well, a 50-foot obstacle. We first need to determine which box this includes. So this box includes this 50-foot obstacle and the pressure altitude of, well, let's read this. It says determine the total distance required to land over a 50-foot obstacle. Pressure altitude of 3,750. 12 knots. Standard temperature. This, because it involves this box because of the temperature, the 50-foot, but it also involves this box because of the pressure altitude. And because of using these two boxes, we need to do another average or mean. So let's go ahead and do that. So the pressure altitude, note that this, reading discussion, note that this altitude lies between 2,500 and 5,000. We got that. Halfway between these two distances is 1,135, right? And the total distance of that 5,000 is 1,195. We see that. You see that this number 2,000 goes with this, and 5,000 goes with this. All right. Since the headwind is 12 knots, the total distance is reduced by 30%. Well, yes, because every 4 knots goes down by 10%. So if there's 12 knots, right? That's not the, if there's 12 knots, we know that this is each that is 4 times 3. That's right, because every 4 knots goes down by 10%. So that means this goes down by 30, and everything starts at 100, so we have to subtract 30 from 100. So that means we're left with whatever our answer is. We need to multiply that by 70%. So I'll put that 70% times our unknown, which we're working on getting right now. So we have these two numbers, so we need to find the average between these two numbers to give us what we're needing. So let's add them. So we have 1, 3, 5, and 1, 1, 9, 5. We get these numbers and then we divide them by 2. All right, we get the sum of that. So we have 1, 1, 3, 5 plus 1, 1, 9, 5. We get the sum of 2,330. Divide that by 2. We get 1165. So that's 1165 will go here. We need to multiply that by 0.70 or 70%. We get 815.5, which we can round off. So just keep in mind 12 knots, right? So that means 12 knots, that's a total of 30%. And we have to multiply that subtract 30 from 100, and we're left off with 70%. So make sure you understand that process. All right. That concludes that. We'll move on to the next question. All right, so next number, 43. All right, so here should be a little bit simple, more simple. Determine the approximate landing ground roll distance of pressure altitude of 5,000. So we're just working with this one specifically. Right, so the pressure altitude 5,000. So we're working with the ground roll 495 only. All right, and we have a temperature. Let's see here. Determine the headwind is calm, but the temperature is high. Temperature is 101 Fahrenheit. So I'll put that on the side. We have 101 Fahrenheit. So we have to work with that. Now let's look at note number 2 for this particular problem. It says increase the distance by 10%. Wow. For each 60 degrees Fahrenheit temperature increase above the standard. Well, standard is 59. So 40, excuse me. All right, standard 15 degrees Celsius is standard. Bear with me for a second. I forgot what standard is. Yeah, 59, yes. So 59 degrees, yes, is standard. So let's see here if we're 60 degrees above standard. If we are, we need to add 10% to the 100. So let's subtract 59 from this. And are we left with 60? Yes, we're going to be left off with 60, all right on 60. So we have to add 10%. So usually we multiply by 100, right? If we have some not issues, then we subtract. But because we have the other way around, it's above, we have to add 10. So this is, we multiply by 110%. And whatever that is will be our answer. So we have 495 times 110%, or 1.1. And we have 545 feet being our answer. All right, so that's how we would do question 43. Question 44. Determine the approximate landing ground roll. So we have a pressure distance of 125. We have a knots, 8 knots and an STD, center temperature. So we're looking at 12,500. Where would that go? It goes on this last box, right? For now. So let's jot down 12,500. No, that's 12,550 we're looking at. So it doesn't go to that box then. I'm looking. Oh, it goes between these two boxes because we're doing 1250. I'm sorry. This is 55, so that doesn't work. So we're talking about these two boxes. All right, so be it. So we have the same situation we need to do. We need to do get the average between them, or the median between them, of 445 and 470, because it's asking for determine the approximate landing roll distance. All right, so we'll do it over here. We have 445 and 470. So that's 915, and we need to by 2. So 2 over 915. So we get 457.5. In the book, they left it as a whole number. So we have 457, and we need to multiply that. Right, and we cannot multiply by 100 because of the knot situation. We have 8 knots. So every 4 knots goes by 10. So we have 8 knots, so we subtract 20 from 100, and that gives us with 80%. Right? So we multiply that, and we get our answer. So that will be 40 times 0.8, and that's 366. Like how I got the 80%, if I wasn't clear, is that remember we always start off with 100%. But because of this, the knots here is 8, right? Every 4 knots, you subtract 10%. So there are 8 knots. So if we were to do 8 over 4, right? That's 2. So that's 20. So we had to subtract 20 from the 100%, just in case if I wasn't clear. So that is 80%. Let's do 45. Okay, 45. Determine the total distance required to land over a 50-foot obstacle. All right, well, they all say 50-foot obstacle. So let's see here. Pressure altitude is 5,000. I see this so far. 8 knots. All right. Temperature is 41. Runway hard surface. All right. Okay. So we have to figure out how much feet then. All right. And looking at the discussion, under standard conditions, this distance to land over a 50-foot obstacle of 5,000 feet is, what is the grounding the feet is 1,195. All right. So we're dealing with this number, 1,195. Temperature is standard, right? Nothing needs to be adjusted. The headwind is 8 knots. Well, that's a situation. So it looks like all we have to do is just multiply that by 8 knots, and we should be good. All right. 8 knots, whatever 8 knots would be. So once again, it's the same thing as the above problem. That's 8 knots. Every 4 knots, you subtract 10%. So 8 would be 2 of those, so that's 20%. We have to subtract that from 100, and we get 80% times 80%, and that should give us our answer. So that is 956 feet. All right. Which was B. All right, 46. Determine the total distance required to land over a 50-foot obstacle. All right. All right, we have the number 7,550. We have 8 knots again, temperature 32, hard surface. So let's see, under normal conditions, the total landing discussion is a clear foot. Obstacle is 1,255, right? Because we are talking about that. And 750, yes, all those numbers belong in this box. Great. The headwind, 8 knots. Yes, we know it reduces by 20, so we are good. This should be pretty straightforward. So we have 1255, and we multiply that by, not by 100% because of the 8 knots. So once again, that goes down to 80, to 80%. We multiply that, and we should have our answer. And we're left with 104 feet. And that is our answer for 46. And that concludes that section.